recording. Put away the chat, put away the participant list, and start to share the screen. So today is basically going to be a conic section day. Try to do the parabola, ellipse, and hyperbola. Okay, the quiz. R equals sine of 2 theta. So the maximum R is 3. Went to 15th circle. Somebody went to 12th circle. Okay, 12th circle is okay. Then each one is a quarter of a circle. That's not too bad. Okay, but 15th is what I talked about that you go out to the 15th. That means R equals 1 is the 5th circle, and R equals 0.2 is 1 circle. If you decided to go the route of 12 circles, then you would have gotten what? 0.25, something like that. Okay, so your chart should be twice as big. It's 2 theta. So cut this in half, 5/8. Cut that in half, 3 5/8. All the way around, 5 5/8, 7 5/8, 9, 11, 13, 15, so on. And my chart is twice as big. So 0, pi. So here's counting every pi over 8, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, 9 pi over 8, 10 pi over 8, 11, 12, 13, 14, 15, 16 pi over 8. Okay. And the reason why you want to write it like this, okay, just go out to one period, is because after that it's just a copy and paste. Okay, put a 0, sine of 0 is 0. That means pi is also 0. Cut that in half, pi over 2. I plug in pi over 2, I'm taking the sine of pi, that's also 0. And keep cutting those in half, divide and conquer. So pi over 4, I'm taking the sine of pi over 2, which is 1. 1 times 3 is 3. If I plug in 3 pi over 4, multiplied by 2, it's 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 1 times 3 is negative 3. All the others have something to do with radical 2 over 2. If I plug in pi over 8, taking the sine of pi over 4, which is radical 2 over 2, is about 0.7. Times 3 is 2.1. Okay, so it's either going to be 2.1 or negative 2.1. Okay, going from 0 to 3, 2.1. Going from 3 to 0, 2.1. From 0 to negative 3, negative 2.1. From negative 3 to 0, negative 2.1. Okay, and once I have this one period, just copy all of these and put them all here. So these just match all these guys. And there we go. And the graph ends up looking something like this. Very nice 4-leaf rows, as it's sometimes called. 4-leaf rows. Okay, 1 leaf, 2nd leaf, 3rd leaf, 4th leaf. And again, you probably noticed we never did anything like this in X and Y. Right? So a lot of shapes that don't exist in X and Y are seen when you do R versus theta. And so here's one of those. Okay. All right, so that's that for the quiz. And now what do we have? All right, so we have one last section, 10.5. I'll either finish all of it today, or I'll do most of it today and finish it Thursday. So we're still okay. We're on schedule for the test a week from today. So that would be November the 10th. Okay, so we're here. I'm already done with 10.4. Okay, and Thursday was dedicated to 10.5. I might finish it today. So I might get started with some of 11.1. Actually, I have a spare day here because this was obviously a mistake. Okay, and again, what I'm aiming for is to try to finish everything so I can give you the last exam on Thursday the 10th, rather than having you take the test 5 on the 15th and the final exam on the 17th. I think it's nice to have 1 week here. Okay, so I'm going to try to finish 10.5 today. I think we might be able to. So we have the parabola, the ellipse, and the hyperbola. Okay, I'm pretty much going to practically boil down to doing almost all the problems. Although again, this is my problems; they may not be the same as yours, but again, you're still learning stuff. Okay, so as I say, you know the way it works, right? If I say I'm doing problem 7, from 13, say, hey, it's not the same as mine. Yeah, I already know that. We all know that, but you're still learning how to do this stuff. Okay. All right, so 10.5. So coverage for the next exam is just this. Then we only, quote unquote, have one more test, but that covers the largest chapter, chapter 11. So we have the rest of the semester to knock this off. Okay, so let's go to our conic sections, the parabola, the ellipse, and the hyperbola for 10.5 today. Okay, so here we go. Okay, so I gave you an introduction last time, but now we'll actually do problems. Okay, so 10.5, the parabola. There are 4 basic parabolas, and I'll give them to you here. You can put these on your cheat sheet if you wish. The ones that you're probably most familiar with are the ones that open up and down. Okay, so a parabola can be defined from a focus, a point, and a directrix. Okay, so we'll be finding a focus and a directrix. Okay, points in the parabola have the property that the distance away from both the focus and the directrix are equal. So I pick a point way out here, right? The distance away from the focus and the distance down to the directrix match. The vertex is an obvious one, right? The distance from there to there matches the distance from there to there. Okay, or this point here, that distance and this distance match, and so on. Okay, so here is our favorite, quote unquote, x squared equals 4py. So if you do all that fancy math, the formula is x squared equals 4py. P is the focal distance. Okay, so I'm going to use capital F for focus, little d for the directrix. The focus here is 0p. The directrix is y equals negative p. So these 4 pictures are, of course, for the vertex of the origin. We know how to translate, right? Move left, right, up or down as necessary. But here's a standard one for parabola opening up. X squared equals 4py. So if p is equal to 1/4, if p is 1/4, then it's our old friend y equals x squared. Okay. Side note, that means for y equals x squared, hidden behind the scenes all the time was a focal distance of 1/4. So the focus would have been 0, 1/4. The directrix would have been y equals negative 1/4. So focus 0p, directrix y equals negative p. Okay, and for a parabola opening down, it's just reverse and put a negative. As you know, x squared equals negative 4py. The focus is always on the inside of the parabola, and the directrix is always on the outside. It's just a mirror image of this. I mean, just take the reflection, right? Reflect across the x-axis. That's going to go down there. The directrix is going to come here. So here the directrix is y equals p. Focus is 0, negative p. X squared equals negative 4py. Now I'm going to hasten to add, if you look at what the text has, Mr. Stewart, he writes it differently than what I have. Technically, what he has is correct, but I don't like the way he does it. Obviously, I'm biased. I like the way that I do it. Okay. If you want to know what he does, he leaves it as x squared equals 4py, but he says p is negative. So he would call this 0, p. And he would actually write y equals negative p here, even though it's a positive number. Okay, so that to me is less intuitive. So I like the way I'm doing it. It's more intuitive, I think. Okay, so we match here. These are the same. His, technically it's correct, but I like this better. So you get the same answer, but y equals p, focus 0, negative p. All right, then opening left and right, you just have a row reversal. X becomes y becomes x. So opening to the right, y squared equals 4px. So it goes like that. Focus is always on the inside. So the focus is p0. The directrix is x equals negative p. Again, we agree on this. We disagree, Mr. Stewart and I, on this. What he has is correct, but he would put a negative there, and I don't like that, and he makes that a positive. But anyway, this is more intuitive. Open to the left, put a negative. Y squared equals negative 4px. The focus is negative p0. The directrix is x equals p. Okay. All right, so I'll get started with the parabola problems. Okay, and the page number doesn't match necessarily, as you know. So I'm just out of curiosity, I'm going to go ahead and take a look at 10.5. So I don't know that it's page 676. And it is not. Page 680, I guess. Okay, but I notice this matches. Okay, so that is the same. And 3 is the same. And 5 is the same. So maybe a lot of them are the same, but whatever. Okay, x squared equals 6y. It's probably too late, but cover it up. Which way does this open? Left, right, up, or down? And if you have a hard time determining that, think of something you're familiar with. You're familiar with that looks like y equals x squared, right? Except for the coefficient. So that tells me it's going to open up. Right? So it opens up. All right. What you want to do is force it to look like x squared equals 4py. Force it to look like that, or like that, or like that, or like that. Okay. So I must go x squared is 4 times something times y. So I have to say to myself, 4 times what number is 6? You're basically solving 4z equals 6. Comes out to be 3 over 2, or 1.5. Okay, so p is equal to 3 halves. That pretty much does it. Opens up. So the focus is 3 halves up. Focus is 0, 3 halves. The directrix, I go down. Remember, the directrix is an entire line. Focus is a point, but the directrix is a line. A horizontal line has equation y equals a constant, y equals negative 3 halves. Okay. All right, number 3, 2x equals negative y squared. 2x equals negative y squared. Which way would that open? It's squared in y, not in x, and there's a negative. So that's going to open to the left. That tells me it's going to go this way. All right, force it to be y squared equals negative 4px. So y squared equals negative 4 times something times x. So the p goes in there. So what do I multiply negative 4 by to get negative 2? 1/2. So the p is a half. And I know it opens to the left because it's squared in y, not in x, and there's a negative. So that tells me it's got to go that way. All right, so there we go. Okay, focus, go half a unit that way. Negative a half, 0. Directrix, go half a unit that way. X equals a half. Okay, so remember, for a vertical line, the equation is x equals a constant. For a horizontal line, y equals a constant. Okay, number 5, x plus 2 squared equals 8 times y minus 3. So I know that's a translation. I would start with the base function, x squared equals 8y. I said function, I shouldn't say function. Some of these are not even functions. All right, that's our base parabola, I should say. X squared equals 8y. Once I analyze that, then I know it's going to move 2 to the left and 3 up, right? Okay, x squared equals 8y. That opens up, right? Think y equals x squared. It's similar to that version. Okay, what's my p? I have to force it to be 4py. So 8 would be 4 times 2. So p is 2. All right, so I know the p is 2. It opens up. The vertex is supposed to be at 0, 0, but the translation law says 2 to the left, 3 up. So my vertex is negative 2, 3. Make it go upward. Okay, and the p is 2, so I go 2 up. That means the focus is negative 2, 5. I go 2 down, draw the horizontal line, so y equals 1. Okay. Okay, 7 is harder. And just see if your 7 matches mine. Your 7 does not match mine. So too bad. Whatever. So you're learning something. And does it show up anywhere? No, it doesn't. Y squared plus 2y plus 12x plus 25 equals 0. So for 7, I have to force it to look like this. So that's completing the square. So throw these two guys over. Subtract 12x, subtract 25. Complete the square. take half the coefficient of y and square it. So half of 2 is 1. 1 squared is 1. So add 1 to both sides. Okay. And then you factor. Okay. So this factors into a perfect square. Y plus 1 squared equals negative 12x minus 24. Factor this, negative 12 parentheses x plus 2. Okay, so y plus 1 squared equals negative 12 x plus 2. So temporarily ignore the plus 1, plus 2. Those are translations. Pretend it's y squared equals negative 12x. So that again looks like this. Y squared equals negative 12x. So if it's negative 12x, what does that force P to be? 3. Right? Y plus 1 squared is negative 4 times 3x plus 2. Okay, so let's see. Squared in y, not in x, and negative. So once again, it's going to open to the left. Okay. And where's the new vertex? So I was at 0, 0, and I shift 2 to the left, 1 down. All right, so 2 left, 1 down. Vertex is negative 2, negative 1, and my P is 3. So I go 3 units to the left, get the vertex, 3 units to the right, get the directrix. So here we go. The new vertex is negative 2, negative 1. 1, 2, 3 to the left is negative 5, negative 1. 3 to the right is on line. The directrix is x equals 1. 3 units this way, 3 units this way, open to the left. There it is. Double check. The focus is always on the inside of the curve. And by the way, that's true for the ellipse. That's true for the hyperbola also. Focus is on the inside of the curve. Okay, so let me lose that. Number 9, they show you a picture. Find the equation. Okay, so how do I find the equation? Vertex is the origin, opens left. So again, as if the version of y squared equals negative 4px. Looks like this. Okay, so for negative 9, let me write that down. Y squared equals negative 4px. And what do I do from there? Well, how about pick a nice point? So that's a nice point. That's a nice point. Okay. How about I pick negative 1, 1? Negative 1, 1 is on the graph. Agree? So over here, I'll say negative 1, 1, plug in. 1 equals negative 4 times p times negative 1. 1 equals 4p. So p is equal to 1/4. Put that back here. Y squared equals negative 4 times 1/4 times x, which is just easily y squared equals negative x, or x equals negative y squared. So that's the equation of that parabola, which is actually y equals x squared just turned over 90 degrees. Okay. So in fact, if I just kind of turn the book, make it look like that, right? That would be y equals x squared. Turn it like that. X equals negative y squared. Okay. Okay. Now the parabolas join up again at 31. Okay. Show you the way Mr. Stewart, the author, does this. So he does the parabolas, and then he does some ellipses, and then he does hyperbolas, and he goes back again to parabolas, ellipses, hyperbolas, right? So I don't know why he does it that way. So I'm going to do all the parabolas. So I'm going to jump now to, I guess, 33-ish, or 31. Okay, and then go back and do the ellipses, and then go back and do the hyperbolas. Okay. All right, so 31, and let me just quickly check. We match on 31. We match on 33, and 35 does not match. But anyway, we still learned something out of it. Okay, so find the equation for the conic section that satisfies the given condition. Parabola, vertex at 0, 0, focus at 1, 0. And yeah, if it looks like I'm ending up just about doing all the problems, you're probably right. Okay, vertex at the origin, focus is 1, 0. Okay, that automatically means the graph's going to go this way. It has to. Okay, so p is equal to 1. This is y squared equals 4px. P is 1. So there it is, just y squared equals 4x. That's all there is to it. Okay, 33 it matches. Says the focus is negative 4, 0. The directrix is x equals 2. Double check again. Yes, that matches, but 35 does not match. But my 35 will show you how to do it. Okay, so I draw it. It's too late since I've already shown it to you. Focus is negative 4, 0. Directrix is x equals 2. Okay, so first, where's the vertex? The vertex is going to be halfway. All right, so from negative 4 to 2, 1, 2, 3, 4, 5, 6 units. So halfway is 1, 2, 3. That means my p is 3. Double check. 1, 2, 3, 1, 2, 3. So p is 3. If this is the focus, that means it has to open left. Okay, so the vertex is negative 1, 0. That's 0, 0 translated 1 unit to the left. So instead of x, it's going to be an x plus 1. Okay. Opening to the left. So opening to the left, we've seen quite a bit of those. Y squared equals negative 4px. The p is 3. So y squared equals negative 4 times 3 times x plus 1. If the focus, if the vertex was the origin, it would just be x. But since I have a translation 1 to the left and nowhere up or down, it has to be x plus 1. Okay, then I just multiply that out. Negative 4 times 3. So y squared equals negative 12 times x plus 1. Final answer. Okay, and finally 35, and I think I'm would have literally done all the parabolas. Okay, I can see that we really wasn't much to it. Again, I should say my 35, which doesn't match your 35. The vertex is 2, 3. Vertical axis, that means a vertical axis of symmetry. And your problem 35 says a horizontal axis. So that means it's going to go like that. So it's either going to open to the left or right. But a vertical axis of symmetry means it's like this. So it's either going to open up or down, but passing through 1, 5. So if it goes through 1, 5, like that, it touches here, that's the vertex. Now I know it has to open up. Okay, so the vertex is here. That's either the highest or lowest point. So it might go down a vertical axis of symmetry, but if it goes through 1, 5, now I know it has to go up. Okay, so it's going to be x squared equals 4py. One of these versions. And then we know it's a shift 2 to the right and 3 up. Okay, so let me take if the vertex were at the origin, right, then it would be x squared equals 4py. Now that the vertex is at 2, 3, that's a shift of 2 to the right, 3 up. So it's going to be x minus 2 squared equals 4p times y minus 3. Right? Now, how do I find p? It goes through 1, 5, plug in 1 for x, 5 for y, and solve for p. So put a 1 right there, put a 5 right there, algebraically solve for p. So 1 minus 2 squared equals 4p times 5 minus 3. Simple algebra. 1 minus 2 is -1. -1 squared is 1. 1 equals 4p times 2. 8p equals 1. So p is equal to 1/8. So the final answer, what's the equation? I put the 1/8 right back there. 4 times 1/8 is 1/2. So this is my final answer. X minus 2 squared equals 1/2 parentheses y minus 3. And here we go. Okay, so I'm done with the parabola, folks. Okay, so I'm ready to start the ellipse. Okay, maybe I'll, what time is 7:40? Got plenty of time. Okay, let me check to see if anybody has any questions. So I'll stop sharing just for a moment. And did anybody have anything in the chat? Does it look like it? Does anybody have any questions about any of the parabolas now? Either unmute yourself or put it in the chat. Otherwise, I'll just keep going.
I think I did have a question about 33.
Yes, sir.
How did you find P for that?
Okay, how did I find P for that? Okay, so let's see. Go back to share the screen. Okay, they gave me this. They gave me this. Okay. Maybe the problem is there's too much information that I gave you. All they gave me was this. Focus, and the directrix was x equals 2. To start. So where's the vertex? It's going to be halfway. So I counted 1, 2, 3, 4, 5, 6. 6 units from there to there. Half of that is 3. So there's the vertex. If the focus is here, I know it's got to go that way. So my P is 3. Sometimes called the focal distance. Distance away from the vertex to the focus. It's also the distance from the vertex to the directrix. 1, 2, 3 also. So that's
how would you know that P is halfway? Halfway between the focus and the directrix. Okay, always.
Yes, it is always for the vertex. I hesitate to say always because they don't give us that many problems that are like that. In fact, this is maybe the only one. But yes, it's true. The vertex is always halfway between the focus and the directrix. So the distance from there to there was 6. So half of that is 3. That's my focal distance. P is 3.
Got it. Thank you.
Okay. All right, you're welcome. In my opinion, just look at the picture. I don't think it's really worth memorizing because this may very well be the only problem that's like that. Okay. Now, if they would give us a whole bunch of problems like that, it might be worth memorizing. In this picture, I just reasoned it out and said, okay, if that's the focus, that's the directrix. The vertex is halfway. So that's that. Okay. All right, any other questions, please? All right, and yes, you may put all these sample parabolas on your next cheat sheet. There are 4 types. Okay. Fortunately for the ellipse, there's only 2 basic types. And for the hyperbola, there's only 2 basic types. So the problem is the hardest, I suppose, although you're probably already comfortable with, well, you for sure should be comfortable with that one and that one because they're functions. These 2 are not functions, but you just kind of tilt them 90 degrees. You got this and this. Okay. All right, so now for the ellipse. So let me give you an introduction to the ellipse again. What you want to know for the ellipse. Okay, page 677. So again, how do you get an ellipse? It's a set of all points such that if you give me a number, the sum of the distances away from the 2 foci, 1 focus, 2 foci, F-O-C-I, is the same. So let's pretend the number is 10. Okay, then for this point P, this distance plus this distance is 10. And if the point's over here, this plus this is 10. And if it's over here, this plus this is 10. And again, if you take 2 pins and hold it down in a string and just make it taut and go that side and that side, you draw the ellipse. do all that heavy duty math. This is what you end up with. X squared over a squared plus y squared over b squared is equal to 1. Okay. That's going to be an ellipse that bulges left and right. Okay. A is going to be the largest number. Okay. It looks like we have a Pythagorean relation, but not the one that you're used to. A is the biggest side. So a squared equals b squared plus c squared. Looks like. Okay. So this plus this is 2a. Okay. You can also show that for this point here, right? If that's a0, that's negative a0. This distance plus this distance is also 2a. All right. So x squared over a squared plus y squared over b squared equals 1. The foci are plus or minus c0, like this. So these are the two foci. It's always on the inside of the curve. Again, if you kind of block out the picture like that, it kind of looks like a parabola where focus inside the curve. Same thing here, focus inside the curve. You kind of block out the rest of the graph. Only look at that, it kind of looks the same. Negative C0, C0. This is B. This is A, but this is also A here. This is from there to there is A. That's A. This is sometimes called the major axis. Makes sense. Guess what that would be? Minor axis, right? So 2A is a major axis as a distance. That's A, that's A. 2B, B and another B, that's the minor axis. Okay, so x squared over a squared plus y squared over b squared equals 1. A being the largest number. Foci plus or minus C0. This is correct. I'd rather you think of it as a squared equals b squared plus c squared. It's a Pythagorean relation. Okay, and the vertices are plus or minus a0. So the endpoints of the major axis are called vertices. So that's a vertex. That's a vertex. One vertex, two vertices. These are the two foci, F-O-C-I. One focus, two foci. One vertex, two vertices. We don't say vertexes. Here's how you spell vertices. Plural of vertex. One vertex, two vertices. So the endpoints of the major axis are called the vertices. What do we call the endpoints of the minor axis? We don't call them anything. Or you can just say they're the endpoints of the minor axis. Okay. These are the two foci, one focus, two foci. Okay, now the other ellipse is bulging vertically. Okay, we're going to call A the larger number. Okay, so notice the equations are very similar, but they go for this kind of ellipse, x squared over b squared plus y squared over a squared equals 1. They just change the designation of A and B. Now, I'll tell you, some books don't do that. Some books will keep it A squared and B squared. It doesn't really change anything, per se. Okay. And please notice the foci are always along the major axis. So if the ellipse is bulging this way, the foci are along the y-axis. If the foci are along the x-axis, it's bulging this way. So these are the two fundamentally different kinds of ellipses. So there are 4 kinds of parabolas, but only 2 kinds of ellipses. One that bulges this way. So the foci are along the x-axis. And the one that's bulging this way, foci are along the y-axis. Okay, so they write it as x squared over b squared plus y squared over a squared equals 1. Okay. In any event, when we're graphing these things, the number under the x is how much you move left and right. The number under the y tells you how much you go up and down. And it's easy to remember because you just look at it, what's above. Okay, above this is x, okay. Above this is y, that goes the y direction. Please notice in the formula, it's b squared and a squared and b squared. So if you want to know how much you go left and right, you have to take the square root of each of these. So let's pretend the number underneath here is 25. that means A is 5. Okay? Or the number under here is 9, that means B is 3. That's the way it will work. All right, so then we can graph it, and we can also get the foci. Remember, the foci are always along the major axis. Okay? And you'll notice the foci are always inside the ellipse. So if it's bulging vertically, it looks like this. The two foci are inside. If it's bulging this way, it's still going to be inside. And it goes this way. Okay. And yes, here we are. Major axis, minor axis. Okay, so the distance from here to here is the major axis. It refers to the distance, but it also refers to the line segment. That line segment is also called the major axis. The minor, so the number would be 2a, the numerical value. Minor axis is 2b, but as a line segment, we can also call that the minor axis. Okay, and the endpoints of the major axis are the vertices, as you can see here. Okay. All right, so I'll start some of these and see how far we get. Okay, so starting with problem 11. Find the vertices and foci and sketch the graph. Okay, so let me just casually check here. 11 matches, 13 matches, 15 matches. And okay, so that's nice so far. And 17, it's a book problem anyway. And then the ellipse problems join up again at 37. So 37 is the same. 39 is the same. 41 is the same. Oh, okay. So they did not change the 7th and 8th edition at all. So all of mine will match all of yours, which is very nice. Okay, so number 11, x squared over 2 plus y squared over 4 equals 1. All right, the first thing I notice is which is the larger number. Well, 4 is larger, so that automatically tells me it's bulging vertically. It'll look like this. A goes with a larger number, so this one's my A. This one's my B. It's actually the square root of these. So A is square root of 4, 2. B is the square root of 2, which is the square root of 2. Okay. Find C, A squared equals B squared plus C squared. Okay, again, that's different than what you're used to. You're used to A squared plus B squared equals C squared. This one is A squared equals B squared plus C squared. Okay, so plug in 4 equals B squared is 2. 2 plus C squared. 2 equals C squared. C is radical 2, which is 1.4. Okay, so we're ready for the graph. Okay, so left and right, square root of 2. So 1.4, 1.4. Up and down, 2. Okay, so the vertices, vertex 1, that's a V1, 0, comma 2. V2, 0, comma negative 2. What do we call these endpoints of a minor axis? Don't call them anything. We can label them as negative radical 2, comma 0, positive radical 2, comma 0, about 1.4. The foci are always along the major axis. That means this time it's got to be this way. Okay, so C is radical 2. And there's another thing. If I went horizontally, the foci would not be inside the circle, because that means the C would match radical 2. Since C and B are both radical 2, it can't be this way because, oh, radical 2, that doesn't make any sense. It's not on the inside. So it would have to be this way. Okay, so I go about 1.4 up, 1.4 down. So F1, focus 1, 0, comma radical 2. Focus 2, 0, comma negative radical 2. And that's pretty much about it. Okay, so notice it's x squared over either a squared or b squared plus y squared over a squared or b squared equals 1. Okay, that's the standard form. So what happens if it isn't 1? You force it to be a 1. Like 13, which starts off like this. X squared plus 9y squared equals 9. Okay, I don't want it to be 9. I want it to be 1. So I divide both sides by 9. So x squared over 9 plus y squared over 1 equals 1. So there we go. So a goes with a larger number. So a is the square root of 9 is 3. Square root of 1 is 1. Okay, so this one's going to be bulging horizontally because I'm going 3 left and right, but I'm only going 1 up. Okay, so let's do our a squared equals b squared plus c squared. If you want to put that in your next cheat sheet, you can. Okay, so a squared is 9, b squared is 1. 9 equals 1 plus c squared. Subtract 1, 8 equals c squared. C is radical 8. No need for plus or minus. A, B, and C are all positive. Okay, so we should write it as 2 radical 2, right? Square root of 8 is square root of 4 times 2. Take out the 4, 2 radical 2. It's about 2.8. Okay, so here we go. So 3 to the left and right. Only 1 up and down. So you can see it's bulging this way. So where are the vertices? Vertex 1, negative 3, 0. Vertex 2, V2, 3, 0. Endpoints of the minor axis, 0, 1, 0, negative 1. And the foci, I go left and right. You can tell you can't go up and down. If I go 2.8 up, I'm outside of the ellipse. So I go 2 radical 2, about 2.8. Now, all the way out to the vertex is 3, so 2.8 is almost all the way out there, right? So here's a case where the foci are very close to the vertices. Okay, so F1, negative 2 radical 2, 0, and focus 2, positive 2 radical 2, comma, 0. And that's that. Okay. Okay, 15. What if they give it to me like this? Well, complete the square again. Another example of completing the square. Now, there's nothing here for y to complete the square, but if they gave me, let's say, plus 8y, then I have to complete the square on y also. But they don't give me any y, so I just complete the square on x. Okay, so first I factor out the 9. So let me cover up the red stuff. So 9 parentheses, x squared minus 2x, right? That's the same as that if you ignore the red. Plus 4y squared equals 27. Now I complete the square. Half and square. What's half of negative 2? Negative 1. Square it, 1. So in red, plus 1. But how come I put plus 9 here? Because when I put plus 1 inside the parentheses, you're really adding 9 to the left side. Okay? You can check. I mean, just take inventory, so to speak. Okay? Multiply this out. 9x squared, there it is, minus 18x. There's the 4y squared, there's the 27. Right? So what's new? Plus 1, but if I distribute, it's really plus 9. So plus 9. Okay. Now when I factorize this, 9 parentheses x minus 1 squared plus 4y squared equals 36. So now that's the way I want it. And you know that's going to be a translation of 1 unit to the right. Okay, so we know the way the game works. I'm supposed to have a 1 over here. So I can force it if I divide by 36. So divide 36, divide 36, divide 36. X minus 1 squared over 4 plus y squared over 9 equals 1. Okay, so the center is not 0, 0. The center is 1, 0. So I have to keep that in mind. Okay, and based on this information, 4, 9. Which way will this bulge? Will it bulge vertically or horizontally? The larger numbers here, that's with the y, so it's going to bulge like that, vertically, because a is 3. I'm going to go 3 up and down, but I'm only going to go 2 left and right. So a is 3, center is 1, 0, b is 2, a is 3, a squared equals b squared plus c squared. So a squared is 9. 9 equals b squared is 4 plus c squared. Subtract 4. C squared equals 5. So c is radical 5, which is about 2.2. The foci are going to be up and down. All right, so I start at my center 1, 0. A is 3. That's up and down. So 3 up, 1, 3. 3 down, 1, negative 3. Vertex 1, vertex 2. For the minor axis, 2 left and right. So 2 to the left, negative 1, 0. 2 to the right, 3, 0. They have no special name. Endpoints of the minor axis, I suppose. Okay, and focal distance is 2.2. And again, notice if you were to go this way, that would take you outside of the ellipse. So you know that can't happen. So 2.2 up, 2.2 down. But when you label the foci, give the exact value. So root 5 up is F1, focus 1, 1 comma radical 5. And focus 2, 1 comma negative radical 5. That's pretty much about it. Okay, then problem 17, time is it? Almost 8? So we'll break shortly. 17, find an equation of the ellipse, then find its foci. Well, this one's actually very easy. How far do I go left and right? 2. Center of the origin, up and down, 3. Wait a minute. Didn't we already do that one, basically? Look at the problem we just did. Can I show you both at the same time? Kind of have to move the book over, come down. Okay, 0, 3, 0, negative 3. 1, 3, 1, negative 3. Negative 2, 0, negative 1, 0. 2, 0, 3, 0. This is just this thing shifted 1 unit to the left. Everything's the same, isn't it? You go 2 left and right, 2 left and right, 3 up and down. So the C is still going to be radical 5. So instead of the center at 1, 0, the center's at 0, 0. That's even better. So what's the equation? The equation is just cover the minus 1. So it would be x squared over 4 plus y squared over 9 equals 1. Right? And then find the foci. Well, instead of 1 comma radical 5, it would be 0 comma radical 5, and likewise 0 comma negative radical 5. Right? So that's it for that. Okay, and then ellipses start up again at 37, 37, 39, 41. Okay, so find an equation for the conic. So what's conic? Parabola, ellipse, hyperbola. That satisfies the given conditions. Okay, so foci plus or minus 2, 0. Vertices plus or minus 5, 0. Okay. Plus or minus 2, 0. Plus or minus 5, 0. Okay, so I put them down. Plus or minus 2, 0, plus or minus 5, 0. It's bulging this way. So A is 1, 2, 3, 4, 5. 5 that way, 5 that way. C is 2. 1, 2, 1, 2. Figure out the B. A squared equals B squared plus C squared. 25 equals B squared plus 4. B squared equals 21. B is radical 21. Punch it in the calculator, it's about 4.5. So 1, 2, 3, 4.5 up, and 1, 2, 3, 4.5 down. So the vertices, I'm not labeling it because they already gave it to me. I'm not labeling the foci either because they gave it to me. I'm only labeling these because they didn't give it to me. So that's 0, comma, radical 21, 0, comma, negative radical 21. Okay. Which means b squared is 21, right? So this is in the y direction, so that goes underneath the y. So here's my equation. X squared over 25 plus y squared over 21 equals 1. And that's about it for that one. Okay, 39 is a little bit tougher. And double check, is that the exact same thing? Yes, it is. Foci 0, 2, 0, 6. So focus 1, focus 2. Vertex at the origin and 0, comma 8. Vertex, vertex, focus, focus. So if I go halfway, that must be the center, right? So the center is 0, 4. So I know I'm going to have a translation of 4 units up. That's going to lead me to a y minus 4 somewhere. Okay, C is 2, distance from the center to either focus. A is 4, distance from the center to either vertex. 1, 2, 3, 4, 1, 2, 3, 4. So A is 4, C is 2. A squared equals B squared plus C squared for the ellipse. Okay. You notice I'm saying for the ellipse. It's because it's going to be different for the hyperbola. Okay. Okay, so A squared, 4 squared, 16, plus B squared equals C squared is 4. Subtract, B squared is 12. B is radical 12. That's 4 times 3. So 2 radical 3. That's roughly 3.5. So I go 3.5 to the left, 3.5 to the right, but you write them as exact values. So don't write it as negative 3.5. That's a rounding off. The exact value is negative 2 radical 3, comma 4, and positive 2 radical 3, comma 4. And I'm ready. B squared is 12. That's how much I go left and right. So the bulge is vertically. Okay, I'm going horizontally. Okay, so x squared over 12, b squared, plus, again, because of the translation, 4 units up, it's parentheses y minus 4 squared over 16 is equal to 1. Okay. All right, and I think it's a good place to break. Okay, so let me stop there and check the chat. Nothing else in the chat. Okay, let's see. It's about 8:06, I see. So let's break until about 8:20-ish. Okay, start up again about 8:20. I'll finish the ellipse and then maybe go on to the hyperbola, and we'll see how far we go. Okay, about 8:20, we'll start up again, please. All right. Okay, folks, I'm going to continue on. There's only one more ellipse problem, and then I'll do the hyperbolas. Then I'm basically done. Okay, now I do realize, I'm dumping the whole truck on you, so to speak. I'm giving you the parabola, the ellipse, and the hyperbola, but at least I pretty much ended up doing all the problems. There's no other extra problems you have to do because I think I would have literally done every single problem. So that makes things a little bit nicer. Okay, so that being the case, finishing everything here. So you have a whole week to prepare for the test. Okay, so Thursday I'll get started with 11.1, I suppose. So we are over here, right? And let's do the same thing as last time. In order to start the test next Tuesday as soon as possible, I'm guessing the strategy that everybody seems to agree with is I'll lecture for a while Thursday, and then let you have a lot of time for questions and answers. And so you can kind of get it all out of the way. So next Tuesday, I'll still lecture a while, but assuming there won't be as many Q&A then, because most of it would have been on Thursday, then you would have more time to be able to take the test next Tuesday, right? So the schedule now would be, I'm finishing 10.5 today, so start 11.1, maybe some of 11.2, Q&A, questions and answers Thursday. Tuesday, lecture a little, let you ask questions, but hopefully you get most of them out of your system, so to speak, by Thursday. Then I can give you more time for the exam next Tuesday, okay? That's game plan for now. Game plan for the rest of tonight, I'll finish up the one last ellipse, then I'll do the hyperbola. So I was going to finish everything, and we still may be able to finish early, and we'll see how it goes, okay? All right, so the last ellipse problem is 41. The center is -1, 4. So you automatically know that's going to be x plus 1 squared and y minus 4 squared, right? Vertex is -1, 0. Focus -1, 6. Okay, so I plotted the points. -1, 4, center. Vertex -1, 0. So 1, 2, 3, 4. That means A is equal to 4. Focus -1, 6. That means C equals 2. So A is 4, C is 2. Well, that's the same numbers as over here. That means B is again 2 radical 3. B is the square root of 12 or 2 radical 3, 3.5. No change. Bulging this way. Okay, so A squared is 16. B squared is still 12. So that's going to be the exact same thing, except it's going to be x plus 1 squared and y minus 4 squared. So there we go. Notice this is almost exactly the same as this. Okay, I can't show you both at the same time, but x plus 1 squared over 12 plus y minus 4 squared over 16 is equal to 1. Okay, and I think I've literally done every parabola and every ellipse, and I might as well just show you every hyperbola problem, so it makes things easier for you guys. Okay, so hyperbolas. It's very similar to the ellipse. Okay, ellipse, x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. Okay, the sum of the distances from the two foci is a constant. So like I said, suppose the value was 10, then this distance plus this distance is 10. And this point over here, this plus this is 10, and so on, all the way around. For the hyperbola, the difference of the two distances is a constant. Okay, so hyperbola looks like this. Okay, this minus this is a constant. Okay, so let me show you. All the algebra turns out to be the same. Let me show you what you end up with. Kind of logical. X squared over a squared minus y squared over b squared equals 1. Same thing, except not a plus, it's a minus. The hyperbola is going to go left and right, like so. Y squared over a squared minus x squared over b squared equals 1. The negative can be over here. That hyperbola is going to go up and down. So there's two basic types of hyperbolas. Going left and right, x squared comes first, or is positive. Up and down, y squared comes first. Y squared over a squared minus x squared over b squared equals 1. Okay. Now, take a look at the way it looks. These are asymptotes. The graph gets really, really, really close to the two asymptotes, but doesn't touch it. In this case, I'll show you how I want you to graph it. Okay, here's a vertex. So these two are called vertices again. As you might guess, the ones along here, we don't call them anything. Notice the foci are still on the inside of the curve. So that was consistent for all three graphs, parabola, ellipse, and hyperbola. If you look just for a small portion of the graph, right, the focus is on the inside of the curve. Looks like, okay, this distance here is A. This distance is C. C is bigger than A this time. For the hyperbola, C is the biggest value. Look at what you got. What we had before for the Pythagorean theorem. C squared is by itself. C squared equals A squared plus B squared. So I know I made you unlearn the Pythagorean theorem for the ellipse. It was A squared equals B squared plus C squared. And then you have to rememorize it back again for the hyperbola. So for the hyperbola, C squared equals A squared plus B squared. So watch out for that. You can put it on your cheat sheet. So the hyperbola, C squared equals A squared plus B squared. For the ellipse, A squared is by itself. Okay, the way I remember is A is the largest number for the ellipse. So A squared equals B squared plus C squared. Okay, so again, two types of hyperbolas. Opening left and right. X squared comes first, positive. Up and down, Y squared goes first. Y squared over A squared minus X squared over B squared equals 1. Okay. So notice the big change here is that you could have Y squared coming first. Okay. Now for the ellipse, we never wrote Y squared first. We didn't have to. So what if I put the Y squared first? Well, there was a plus, and we know addition is commutative. That means you can switch the order for addition, so it wouldn't have mattered. But we know subtraction is not commutative, so these could be different. Something else about the hyperbola, A and B have no relation in terms of which is bigger or smaller. Okay, A might be bigger than B, A might be less than B, A could even be equal to B. Those are all allowed for the hyperbola. So for the ellipse, you might recall we said A was going to be bigger than B. Not for the hyperbola. For the hyperbola, no relation. A can be bigger than B, B can be bigger than A, or they might even be equal. Okay. Other than that, though, look at the equation. It looks very similar to the ellipse. So if you understood the ellipse, the hyperbola is very similar, except that there's a minus sign. Okay. Now, I will have to show you how I want you to graph these things. Okay, so here we go. Okay, so the hyperbola, there's only 6 questions, I think. 19, 21, and 23. And then 43, 45, and 47, 6 problems. So if I knock them all off, we're done. And there really literally is no homework for you to do except to go back and study it. So, I mean, you talk about doing 70% of the homework. It looks like I'm going to end up doing 100% of this section's homework. Okay, but let me make a comparison. 19 matches. Checking, you can't see it. Okay, 19 matches. 21, where's 21? Okay, that matches. 23 does not match. Okay, my 23 is harder. Okay, so if I show you the harder one, maybe you can do the easier one. As you might guess, there's going to be completing the square. Okay, then let's see. 43, identical. 45, identical. And 47 is identical. Okay, so the only one that's different is I got a harder version of 23. So if I do the harder one, you should be able to do the easier one. Okay. Okay, 19. Y squared over 25 minus x squared over 9 equals 1. We're going to call the number in front A and this one B, okay, regardless of which one's larger for the hyperbola. Okay, Y comes first, so I know it goes up and down. And by the way, this is considered one hyperbola. There's two branches, so there's a branch here and a branch here, but these two combined are considered one hyperbola, even though they're disconnected. Okay, so A is 5, B is 3. A squared plus B squared equals C squared for the hyperbola. Okay, for the ellipse, it was A squared equals B squared plus C squared. Okay, let's see, A squared is 25, B squared is 9, C squared is 34. So C is the square root of 34, that's about 5.8. Okay, here's how I want you to draw the hyperbola and the asymptotes. You're going to draw a box. Okay, now the book doesn't have the box. I want to see the box. That's my rules. Okay, sometimes it's called a fundamental rectangle, fancy term. It's just a box. Okay, you start off by plotting these 4 points just like the ellipse. So pretend this was an ellipse problem. You would go 5 up and down. It's underneath the y, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 left and right. Okay, so if this were an ellipse problem, I would just round my ellipse and go like that. Okay. But since it's a hyperbola problem, instead I make myself a box. So these 1, 2, 3, 4 points. Now you have to be careful. You don't just connect these 4 dots. Don't go like that and make a diamond. You have to draw only horizontal and vertical line segments. So you take these 4 dots, just go straight up and down and across and down and across. So you draw yourself a box, the fundamental rectangle. Then you connect the diagonals. They should go through the center. The diagonals are going to be your asymptotes. You curve them toward it. Okay, what are the equation of the asymptotes? Well, they go through the origin and rise over the run, right? 1, 2, 3, 1, 2, 3, 4, 5. So the slope is 5/3. And this will automatically be negative 5/3. So the equation of the asymptotes they ask for, and I might ask for in a test, y equals 5/3 x, y equals negative 5/3 x. So there we go. Okay, since I already knew it's going to be up and down, right? How do I know? Y comes first. If x came first, it would be left and right. And I'll show you one of those. So I take the 2 vertices, that one and that one, and curve them toward the asymptotes. So the actual asymptote, the actual curve is that and that. The box is not part of the hyperbola. The asymptotes are not part of the hyperbola. Only this curve and this curve combined are considered one hyperbola. Okay, so vertex 1, vertex 2, vertex 1, 0, 5, vertex 2, 0, negative 5. The foci, I go 5.8, almost 6. So F1, focus 1, 0, comma, radical 34. Focus 2, 0, comma, negative radical 34. It's about 6 units down. Okay, I want you to notice for all the shapes, parabola, ellipse, hyperbola, if you look at a very small portion of the curve, it looks like the focus is on the inside of the curve, right? Okay, so if you look only at a small portion, right? Okay. Focus on inside of the curve. Look at a small portion of the ellipse, it's going to cover everything else, right? See, if I just show you that portion, you can't really tell, is it a parabola, ellipse, or hyperbola, right? They all have the same general idea, focus inside of the curve, right? I mean, if you don't know any better, this could be either a parabola or an ellipse or a hyperbola, right? So if you look only at this part, same thing, focus inside the curve. So that's one way you can tell for all the shapes, parabola, ellipse, or hyperbola, you can tell if you did it right, the focus should always be inside the curve. Okay, so there we go. Okay, 21. X squared minus y squared equals 100. Well, I don't want 100. I want 1. Divide by 100. X squared over 100 minus y squared over 100 equals 1. That means A and B are 10. X is first, so it's going to go left and right. Okay. Y was first, so it goes up and down. I go the same distance left and right as I do up and down. Okay. If this were a plus, that would mean we actually have a circle. Right? In fact, you can think of a circle as a special case of an ellipse, okay, where you go the same distance left and right as you do up and down. Right? So this would be 10 in every direction. So from the origin, I go 10 left, 10 right, 10 up, 10 down. So if this were an ellipse problem, I would just round it like that, and your ellipse, quote unquote, would actually be a circle. But no, it doesn't matter in this case. So again, A and B can be equal. A can be bigger than B. A can be less than B. It doesn't matter. It's still a hyperbola. The only difference this time is my fundamental rectangle is a square. So draw my square, draw my diagonals. That's easy. Y equals X. Y equals negative X. Slope is 1. Slope is negative 1. Okay, and since it's curving left and right, I take the two vertices, which are negative 10, 0, and 10, 0, and curve them toward the asymptotes. And the last thing are where the foci. A squared plus B squared equals C squared. 100 plus 100, C squared. C squared is 200. C is the square root of 200, which is 10 radical 2. It's about 14.1. All right, so I go out to about 14 and 14. So focus 1, negative 10, if you can't read that, it's 10, negative 10 radical 2, comma 0. Well, that number. Negative 10 radical 2, 0. Positive 10 radical 2, 0. So notice again, the focus is on the inside of the curve. Focus inside the curve. Okay, and then my 23, which is not the same as your 23, but harder. 4x squared minus y squared minus 24x minus 4y plus 28 equals 0. Okay, so if you know how to do this one, you should be able to get your 23. This is a much harder problem, actually. Okay, so that's going to be completing the square. Okay, I've got x squared and x, y squared and y. So throw the 28 over, becomes negative 28. Okay, now look at these two. 4x squared minus 24x. Factor out the 4, not the 4x, just the 4. X squared minus 6x. Ignore the red. Double check. 4x squared minus 24x. Agreed? Minus y squared minus 4y. I'm going to go minus parentheses y squared plus 4y. So far, same thing. Again, inventory. Double check. Ignore the reds. There's no reds. 4x squared minus 24x. There it is. Minus y squared minus 4y. Correct. And the plus 28, I subtracted over negative 28. Okay. Now the red stuff. Complete the square. Half and square. Half of negative 6, negative 3. Square it, plus 9. But this plus 9, because of the 4, it's really plus 36. So plus 9 really is plus 36. Likewise over here. Complete the square. Take half and square. Half of 4, 2. 2 squared is 4. So plus 4, but it's really a minus 4. So minus 4 there. Okay, this comes out to be 4. Negative 28 plus 36. 8 minus 4 is 4. Factor these two. 4 times x minus 3 squared minus parentheses y plus 2 squared is equal to 4. Okay. Now, I believe if you understood this problem, you really should get your version of number 23 because it only has one of them. It's much easier. Okay, divide by 4. x minus 3 squared over 1 minus y plus 2 squared over 4 equals 1. Okay, so I've got it. Translate it. Center is 3, negative 2. 3 to the right, 2 down. So the new center is 3, negative 2 instead of 0, 0. A is 1. B is 2. So notice we're not switching the designation depending on the size. Okay, A can be bigger than B. A can be less than B. A and B can be equal. We're still going to call A to be the number that's in front, the one with the positive. Okay. I guess you could still argue, because this is positive, this is negative, any positive number is larger than any negative number. So in that sense, you could still say this is larger. You can say 1 is larger than negative 4. So if you think of it that way, then that still follows the idea that A is going to go with the larger number. But be that as it may. So I start at the center, which is not the origin. It's at 3, negative 2. So 3, negative 2. Left and right, 1. Up and down, 2. Draw the diagonals. Should go through the center. Okay, x came first. So that means it's going to go left and right. So the two vertices are here and here. They are 2, negative 2 and 4, negative 2, because the center was 3, negative 2, right? So if I go 1 to the left, 2, negative 2, vertex 1, vertex 2, 4, negative 2. I put it over here because otherwise the picture gets too crowded. Okay, so that's what the hyperbola looks like. Okay, a squared plus b squared equals c squared. So a was 1, b is 2. 1 plus 4 equals c squared. C squared equals 5. C is radical 5, 2.2. So 1, 2, and a little bit. 1, 2, and a little bit. But write the exact values. This was 3, comma, negative 2, center. So if I go root 5 to the left, you should write it as focus 1, 3 minus radical 5, negative 2. Focus 2, 3 plus radical 5, negative 2. Okay, last thing is, how do you write these asymptotes? Well, they both go through the same point, which is nice. So I should do the point slope form. The center is 3, negative 2. So that's x1, y1. The only difference is the slope. So what's the slope of this one? Well, it's over 1 up 2, so the slope is 2. The slope is negative 2. They both go to the same point, 3, negative 2. So the equation of this asymptote, y plus 2, y minus y1 equals m2 times x minus 3. Again, that's y minus a minus 2, y plus 2 equals 2 times x minus 3. This one's exactly the same, except the m is negative 2. So y plus 2 equals negative 2, parentheses, x minus 3. And I wrote it crooked in order for me to fit it. I didn't think I could fit it any other way, so I just wrote it like this. Okay. All right, then 43, 45, and 47. Find the equation for the conic, the hyperbola. So since it just asked for the equation, once we have the equation, we can stop. We don't have to draw the graph. We don't have to find all the other fancy stuff if we don't want to. Okay, so 43. Vertex is plus or minus 3, 0. Foci are plus or minus 5, 0. So here's negative 3, 0, 3, 0. A is 3. Focus, negative 5, 0, 5, 0. C is 5. Well, you know your Pythagorean theorem very well. B is 4. 3, 4, 5, right? Or you can go, a squared plus b squared equals c squared. I highly suspect you all know the 3, 4, 5 triangle. If you don't know it, do your a squared plus b squared equals c squared. B is equal to 4. Okay, it's going left and right. That means x squared is first, y squared is second, center to the origin. So I don't have to go x minus something or y plus something or whatever. A is 3, x squared over 9. B is 4, minus y squared over 16 equals 1. And that's it. We're done. That's all you need to do for that one. Okay, 45 is definitely harder because they give us numbers that are not as nice. Vertex is -3, -4, -3, 6. Oh boy. Foci, -3, -7, and -3, 9. Okay, so a lot of stuff is happening at x equals -3. So it must be going this way. Let's find the center. How do I find the center? Well, it's either halfway between the two vertices or halfway between the two foci. You know it's going to be -3 something. So what's halfway? I can average them. Average -4 and 6. Add them up and divide by 2, right? So -4 plus 6 is 2. 2 divided by 2 is 1. So the center is -3, 1. You do the same thing here, right? What's the average of -7 and 9? Well, add them up. -7 and 9 is 2. 2 divided by 2 is 1. Okay, so the center is -3, 1. Okay, that means it's going to go up and down, which means y comes first. So automatically, based on this, it's going to be y minus 1 squared minus x minus a -3 or x plus 3 squared over something equals 1. So I'll cover up that. You already saw it. But right now, I know it's up and down, okay, because the foci are here and the vertices are here. So that means if it goes up and down, y is first. Center is -3, 1. So y minus 1 squared minus x plus 3 squared equals 1. So I just have to figure out these numbers underneath. Now, a is 5. How do I know what's 5? Distance from the center to either vertex. So how far is it from -3, 1 to -3, 6? 5 units. Or how far is it from -3, 1 to -3, -4? 5 units. That confirms it. Same thing for the focal distance. I claim it's 8. Okay, how far is it from here to here? Well, how far is it from 1 to 9? 8. And likewise, how far is it from 1 to -7? Also 8. So C is 8. A is 5. Since A is 5, that automatically means 25 goes here. And what goes under here? Do my A squared plus B squared equals C squared. Okay, A is 25. C squared is 64. Okay, subtract 25. B squared is 64 minus 25 or 39. B is radical 39. But what goes under here is B squared, so 39 goes here. So this is the final answer. Y minus 1 squared over 25 minus x plus 3 squared over 39 is equal to 1. Okay. All right, 47, and I'm done, folks. That is the last one. So I'll be done in a few minutes. So after a few minutes, I would have finished everything you need for the chapter. And I've literally done just about every problem except for the one where the book was different. I guess it was 23 and maybe some other ones. Okay. So you know exactly how to study for next Tuesday's test. Okay. So as soon as I finish this last problem, I'll blab a little longer. Then you can ask me stuff, but if you don't want to ask any stuff, we can just call it a day and leave. Okay. So that means Thursday I will start 11:1, but you be prepared Thursday for any questions that you want from chapter 10. That way, again, we get it out of our system, so to speak, so we don't have to ask as many questions on Tuesday, so you can have more time for the test. Okay, so be prepared for a lot of questions if you have any on Thursday. And you can ask tonight also if you wish. That's up to you. Okay, so 47. Vertex is plus or minus 3, 0, and the asymptotes are y equals plus or minus 2x. I should show you the text for that one, I suppose. So hyperbola, vertices are plus or minus 3, 0, asymptotes y equals plus or minus 2x. Okay, so -3, 0, 3, 0. That means we're centered at the origin. Nice. So I go 3 that way, 3 that way. A is 3. Well, the slope is 2 and negative 2. Rise over the run is 2, which means if I go 3 as a run, the rise ought to be 6, because 6 divided by 3 is 2, right? That means the graph looks crudely something like this. Is that right? Okay, one more time. The A is 3. Asymptote is y equals 2x and negative 2x. That means if the slope is going to be 2, it's rise over the run. The run is 3. That makes the rise 6. Now, I can figure out the c, but I don't need to. It just asks for the equation. Okay, it's opening left and right, so x squared comes first. X squared over a squared, x squared over 9, minus y squared over b squared, 36 equals 1. And there we are, folks. Okay, so I know I gave you a lot of stuff tonight, the parabola, the ellipse, the hyperbola, but I pretty much gave you everything. There's hardly any homework problems for you to do. You just go back and review it, I suppose. Okay. All right, about 8:55. I'm done, folks. So let me stop the share. And let me check the chat. And there's nothing in the chat. Okay, let me get my notepad out. So technically, we still have half an hour, but that's up to you. So I will let you ask questions. But if there isn't anything, we can call it a night. But if so, come with any questions next time, since I'm officially done with chapter 10. And I'll get started with our last chapter, chapter 11, next time. Okay, so anybody want to ask me anything? Otherwise, we can quit. So any questions, please? What textbook is used for Calc 3? We use the same textbook. Okay, so you don't have to get a new one. So yeah, if you plan to take me, I will have the problems match this time. So there's no fiddling around with second and third edition. So I'll be able to keep all the problems. We won't have the same issue that we have this time. Okay. All right, anybody else, please? You can either unmute yourselves or put it in the chat. All right, hearing nothing, then we can adjourn. All right, so that'll do it, folks. So next time I'll start a section, but your quote-unquote homework is come up with any questions you might want to have from chapter 10, and that just saves us some time for next Tuesday. So again, that way you have more time for the test on Tuesday, okay? All right, that'll do it for tonight, folks. So have a good evening, and we'll see you. Okay, have a good night, everybody. Okay, bye.